In this lesson, we'll create an external thread cutting toolpath. After completing this lesson, you'll be able to create an external threading toolpath, analyze a toolpath simulation, modify geometry using press-pull, and modify tool geometry. For this next lesson, we want to go back to our external threads file and talk about cutting threads using our turning toolpaths. Just as a quick reminder, if we use inspect measure, we can measure the outside diameter of each section. This one measures at 1/2 inch, and this one here measures at 0.561. We're going to be creating two different threads. We're going to be creating a 1/2 by 13 thread on the smaller section and a 9/16 by 12 thread on the larger section. With that information, we're going to go into turning, and we're going to select turning thread. We first need to start by selecting a tool. So again, we'll come in and we'll use our type filtering options, and this time we'll select just threading. Then we're going to focus in on our vendor library. We're going to grab tool number 5, and if we look at its parameters, we can see exactly what they are in terms of its geometry, and note that it's listed with a thread pitch of 0.05. What this means is I can't use it for something that's going to be less than that amount. Since our thread pitches are going to be relatively larger than that, we don't have to worry too much about it, and we can still use the tool as long as it can cut deep enough. We are going to be doing outside threading, and we're going to navigate into our other options. Next, for geometry, we have containment and threaded faces. Because we've gone through the process of removing the modeled threads on this, we can go ahead and simply select the face where we want the threads to start. And notice that on the screen we instantly get a preview of the toolpath. The front side stock offset is currently a 1/4 inch, which is a little bit too much, so I'm going to reset this to 0.1. And the back side offset is set to 0, but I'm going to increase it to go into that groove. So I'm going to add 0.07 to take it into that groove and start to come away. We're not going to modify any of the radii settings, but because we did have a larger piece of stock, we could reduce these to make sure that the tool stays a little bit closer. For example, the stock OD right now, plus 0.4, so you can see where the tool is starting. If we were going to actually cut this part, we would want to keep it a little bit closer. Next, in the passes section, we need to actually tell it exactly what threads we're cutting. So right now it brings in the thread pitch directly from the tool. Now this thread pitch is not correct. When we're looking at doing a 1/2 by 13, the thread pitch is actually 0.0769. And you can get that by using 1 divided by 13, and that'll give you the thread pitch. The thread depth is another value that we need to modify. Right now it's set to 0.04. However, when we're talking about the difference between a 1/2 inch diameter and the minimum diameter value of a 1/2 inch by 13 thread, we have a difference of 0.0479. And there's also a trailing 5 on that, but I'm going to leave it at 0.0479. So when we talk about these numbers, these come directly from a thread chart. They are dependent on the geometry size that we're dealing with, as well as specifics about the class of thread. So right now the number of step downs is set to 5 by default, and we'll go ahead and utilize that. The other parameter that we want to modify is going to be the in-feed mode. A quick note that the do multiple threads option will allow you to create threads with multiple starts. We're not going to be exploring that option here in this course, so we're going to focus our attention on some of the more common settings. Right now we have constant in-feed, reduced in-feed, and alternate flanking. The reduced in-feed option will allow us to maintain some realistic cutting forces that reduce the depth of cut with each pass. So this is going to be the most common option to use when we're setting our in-feed values. And generally, the in-feed angle will be about 1/2 or a little bit less than 1/2 of the angle of our tool. So most of our threading tools will be 60-degree tips, so we're going to enter a value of 29.5 degrees. We have the option to fade the thread end, which is going to be the tool motion you see at the end of this, where it's sort of working its way away from the part. Then we also have a spring pass. If we want to repeat the last pass, we can use that. Under the linking section, we have a full retraction policy, which we can do minimum retraction, And then we also have approach and retract to the safe Z distance. And I'm going to leave those values as well and say OK. To validate this, we're going to go into Setup. We're going to make sure that we have all of our toolpaths selected and then Simulate. I'm going to jump ahead a few toolpaths to make sure that I get down to exactly the area where we start threading. Then I'm going to play forward, taking a look at the threading toolpath. So as we're looking at this, you can see that the tool is coming completely away from the part, moving its way back in and cutting each pass. But you'll notice that we're not seeing any threads. And this is because our model doesn't contain physical threads. The actual geometry is going to be smaller than the diameter of our part, so we'll need to hide that model. Now you can see underneath that we have our 1/2 by 13 thread. If we rotate this around, you'll see there's a small amount that's left behind, which tells me that I either need to modify the geometry, which will allow me to change the width of the groove that's in the part, or I need to change the way that we're cutting and exiting the cut by extending it out a little bit farther. There are multiple ways that we can do this, and generally when you have a thread that ends at a larger diameter, we will want to have that groove in there. So let's take a quick look at how we can modify the geometry, and then we'll come back and update the threads. So we're going to navigate back to the design workspace. We're going to come in and we're going to use the press pull tool, and we're going to grab this face and we're going to pull it forward a distance of 0.03 and say OK. So now we've modified the width of that groove. If we go back into our manufacturer workspace, you'll notice our toolpaths need to be regenerated. Again, you can do this by right-clicking and selecting Generate, doing Ctrl-G on the keyboard, or by going to your Actions and Generate. So now we have our face, our profile, our single groove, and you'll notice the single groove no longer fits because the tool isn't wide enough. And then we have our chamfers, and then we have our threading toolpath. Because we did modify the groove, we do need to make some adjustments to our single groove tool or to our single groove operation. If we inspect this now and we measure the distance between these faces, you can see that we have a distance of 0.093. So this tells me that for my single groove operation to work, my tool needs to be 0.093 wide. We can modify that if we have a tool that meets that requirement, or we can go back and use a different toolpath like turning groove that will allow us to slide and move the tool inside of that groove. But I'm going to go ahead and enter a value of 0.093 and just make my tool wide enough for that groove, update it, and regenerate that toolpath. So now if we select Setup and we go to simulate this, I'm going to jump all the way to the end. Again, we want to hide our model. And note now that the thread ends perfectly and it doesn't have any remaining material that needs to be taken off. Again, there are other ways that we can do this, but traditionally we want to make sure that we have the right tool to get in and cut the threads. We also want to make sure that we have the room to be able to do this, especially if we're butting up against a larger diameter. From here, we are going to explore creating the larger thread, but this is a great time for us to save what we've done before moving on to the next step.